Today we're going to be working on 3.3, which is dividing polynomials and talking about the remainder theorem. So the big idea behind polynomial division is if we are given a specific factor or zero of a given polynomial, we can use this information to divide and find the remaining factors or zeros, even when we can't factor solving using methods learned up to this point. So with this idea, if we use the fact that 4 is a factor of 20, we can find another factor of 20, right? We would just use regular division. 20 divided by 4 would give me 5, because 5 times 4 is 20, and you get 0. So another factor is 5. It works the exact same way. We're going to use two types of division today. We're going to use long division of polynomial functions and synthetic division of polynomial functions. So this slide is to remind you, using the vocabulary, what we do when we divide. So we have what's called the dividend, which is the answer, okay, or what you're trying to divide. So in this case, it's 16. Then we have the divisor, which is the factor or the zero that we know, which is 3. And then we have the quotient, which is the other factor that we need to multiply to give us the dividend. And then we have the remainder if it's not an exact answer, right? So if the remainder is 0, then we know that the divisor and the quotient are both factors. So let's take a look. When we're performing polynomial long division, we want to write each polynomial in descending order and be sure to include missing powers. So this is important. If you have x squared plus 3 here, you need to make sure that you write it as x squared plus 0x plus 3 so that you don't miss a term. That is very important. Okay, and then we're going to perform polynomial division using the steps that we're going to do in the next couple of examples. And then we're going to write the answer in the form of the quotient plus the remainder over the original divisor. So let's go ahead and look at some examples. So we're going to use long division. So we're going to divide x cubed plus 2x squared minus 5x minus 6 by x minus 2. So first we're going to set it up as a long division problem. So we have x cubed plus 2x squared minus 5x minus 6. We aren't missing any terms here, so we don't have to worry about that. And then we're going to divide by x minus 2. So then we're going to think about it in terms of x, okay, right? If I wanted to multiply something times x minus 2 to give me x cubed plus 2x squared, I would need to multiply this x by something to give me x squared, right? So this x by something to give me x cubed, right? So if I want to get, again, this idea is we're taking this x and we want to turn it into an x cubed. If I want to get an x cubed from an x, I need to multiply by x squared. We're going to line that up with the x squared term here. So then we multiply just like we would multiply in regular division, right? So I'm going to multiply this x squared times this whole divisor here. So x squared times x gives me x cubed, and x squared times negative 2 gives me negative 2x squared. So we have to remember that we're using subtraction when we are doing this. So when we use subtraction here, we're distributing that subtraction to both terms. So this is going to become negative and this is going to become positive when we actually look at it. So what happens here is our x cubes cancel and we're left with 2x squared plus 2x squared right here. So we get 4x squared. So now we're doing the same thing. We're trying to figure out how to make 4x squared from an x. So to get 4x squared, we're going to do x times 4, right? So if we have minus 4x here, and then we multiply that, we're also going to bring this down so we have a term to keep going with, just like we would in regular division. So negative 4x times x will give us, plus. We need a positive there because we need a positive 4x here. So 4x squared minus 8x. And again, we're doing subtraction here. So these two cancel, and we're left with negative minus minus. So this becomes plus here. So we get negative 5 plus 8 will give us positive 3. So we get 3x there. Bring down our minus 6. So again, now we're trying to get 3x from an x. So we need to multiply times 3. So then we multiply again, distributing. So again, when we multiply, we get 3x minus 3 times 2 is 6. And so this time, they both cancel, and we're left with 0. So what that means is that our solution here is x squared plus 4x plus 3. And because our remainder is 0, we don't need to write the remainder portion. So we just have qx is equal to x squared plus 4x plus 3. All right, let's look at another one, because this is a process that you have to get used to. So we're going to look at it again. Okay, I'm not going to change colors as many times here. I'm just going to work through it slowly. So we have x cubed minus 2x squared. We're missing our x term here. That's important. So I'm just going to write plus 0x minus 7. So we have to add that plus 0x here to account for that term that's missing. Divided by x plus 2. So again, x to an x cubed, I'd have to multiply by x squared. So x squared times x gives me x cubed. X squared times plus 2 gives me plus 2x squared. We're subtracting here. So these cancel. This becomes subtraction. So we end up with 2 minus 2x squared to give us negative 4x squared. And bring down the next term. So to get negative 4x squared, we need to multiply by a negative 4x. So negative 4x times 4x gives me a negative 4x squared. Negative 4x times positive 2 gives me a negative 8x. This is being subtracted. So those cancel. A negative and a negative makes a positive. So this is 8x. So then I'm going to bring down my negative 7. So to get a positive 8x here, I'm going to do times 8. So I get 8x minus 16. So we're subtracting there. So this cancels. And we get plus here when we put that negative through. So we get a 9. So our final answer here is we have our quotient q2 minus, or x squared minus 4x plus 8, plus, then we have to take our remainder, 9, and put it over our divisor, x plus 2. So you can see that this is the quotient part, and this is the remainder plus divisor part. And so that whole thing is our final answer. Okay. Let's do one more together, and then we'll move on to synthetic division. So here we have 9x cubed plus 15x squared minus 12x minus 32. It has all of its pieces, so I don't need to worry about a missing term. So then I have 3x minus 4. So to make 3x 9x cubed, I would need to multiply by 3x squared. So 3x squared times 3x would give me 9x cubed. Remember, we're subtracting. So 3x squared times negative 4 would give me negative 12x squared. So these cancel. This becomes a plus when we put that negative in. So we get 27x squared. Bring down our next term. So now we're trying to make 27x squared from 3x. So we need to multiply by positive 9x. So we get 27x squared. Again, subtraction. 9x times negative 4 will give me negative 36x. And put that negative in to make it a positive. So we have 36 and negative 12, which will give us a positive 24x minus 32. So then we're trying to make 24x out of 3x. So we're multiplying by a positive 8. So 8 times 3 gives me 24x here. 8 times negative 4 gives me a negative 32. So that goes in and makes that positive. So we get 0 here. So this time our solution is 3x squared plus 9x plus 8. All right, so let's look at synthetic division. So for synthetic division, we're going to write each polynomial in descending order, just like we did before, and put in zeros where we need to for missing values. Then we're going to perform synthetic division. It is very special. Right here, we put our c value. So if we have x minus c, it would just be a positive c here. We put the coefficients from the original equation here. And what we're doing is we're simply adding here. And so we're going to bring those, it's a multiplication addition issue. So I'm going to model it for you because that will make more sense. But setting it up like this will help us start. So if we wrote just the coefficients here, we have negative 4. We have a positive 1 that we don't write. We have a positive 6. We have a 2. There's no x term, so we know that it's 0x here. So that's the 0 here, and then our c value. X minus 2 means that our x is 2 here. So that's what goes right here, is that x is 2. So then what we're doing is we're simply bringing it down, multiplying, and then bringing that up and adding. So here we're multiplying, here we're adding. And we do that all the way through. And then when we do, we're going to end up with a final answer with this that's blocked off over here as our remainder. So let's look at some together. So just setting this up first to begin with, we have to have x minus 3 solved. So that's 3. So we have 3 as our divisor. So then the coefficients that we're using is 1, because there's a 1 here, 5, and -7. We know our remainder will be in this last spot here, and we know we're adding this whole time. So there's nothing here to add to. We drop that down because it's our first one. So 1 times 3 gives me 3. So then I'm adding 5 and 3 to give me 8. Then 8 times 3 gives me 24. Then add 24 and -7 to give me 17. So then my solution in this form here, I'm going to write it down here, is x plus 8, because that's all you're doing here. This becomes 1 less here. We had an x squared, so we're going down 1. So x plus 8 is from here. Plus 17 over our original divisor, x minus 3. So this is our final answer. Okay, so for this next one here, we're going to do the same thing. First, if we have x plus 2, we solve that to get a -2. So we have -2 as our divisor. And then we bring down our coefficients. So I have -12. Oh, what's happening here? I have a squared and then a fourth. So we're going to have to rearrange these first. So let me rearrange these. We're going to have 3x to the fourth, and that's positive. Then we have minus 12x squared. Then we have plus 8x, and then we have plus 4. So I had to rearrange in descending order first. I do see that I'm missing a value, right? I went from an x4 to x squared. So let me rewrite that again to include that 0 on the cube. So that's what we're really looking at, is 3x to the fourth plus 0x cubed minus 12x squared plus 8x plus 4. So now we can put those down as 3, 0, -12, 8, and 4. And we know when we have a remainder, it will be here. So first we bring down our 3. 3 times -2 gives me -6. Bring down our, add 0 and -6 to give me -6. -6 times -2 will give me positive 12. So this term will zero out. Well, then 0 times -2 is 0. So that gives me 8 here. So 8 times -2 is -16. So then that gives me -12 here. So this was x to the fourth, x to the third, x squared, x, and our constant. So this time this is going to be x to the third, x squared, x, and our constant, and our remainder. So when I rewrite, we have 3x cubed minus 6x squared plus 8, because I don't need to write that 0 term, plus -12 over our original divisor, x plus 2. So this is our final answer. Okay, let's look at another one. So here we have t to the fourth minus 256. We have to have those 0 values again. So we're going to have 1 for the fourth power. If you remember, this is t to the fourth. So then we need t to the third, t squared, and t, and then our constant. So 0, 0, 0, and our constant is -256. Here you solve this. 4. And then we set it up just like we do the rest. So first I'm going to bring down 1. 1 times 4 is 4. 4 plus 0 is 4. 4 times 4 is 16. 16 plus 4, or 16 plus 0 is 16. 16 times 4 is 64. 64 plus 0 is 64. 4 times 64 is 256, and that's 0. So we don't have a remainder this time. So our solution here, remember we drop 1, so that's T3, T2, T, and C. So our final answer is T cubed plus 4T squared plus 16T plus C, or 64. So this is our solution for this one. Okay, let's look at another one. So here we have, we're told that 4 is a 0, so we don't need to solve anything. 4 is what we're going to use here. So then we have x to the third, so 1, negative 4x squared, so negative 4, 4x, so 4, and negative 16 is our constant. So again, this is x cubed, x squared, x, and our constant. So same thing, 1 times 4 is 4. Negative 4 plus 4 is 0. 0 times 4 is 0. 4 plus 0 is 4. 4 times 4 is 16. Negative 16 plus 16 is 0. So this is now our squared term, our x term, and our constant term. So our solution here is simply x squared plus 4. All right, so we talked about how, since we did the long division and synthetic division, now we're going to talk about the remainder theorem. So if the polynomial f of x is divided by x minus c, and the remainder is f of c, that is, if f of x equals x minus c times q of x plus r of x, then f of c equals r of x. Why? Why do we care about that? What happens to f of x is it equals x minus c times q of x plus rx when you substitute c for x. So if we substitute c for x here, then we get c minus c times q x plus rx. So then this becomes 0 times q x plus rx. So then this just becomes rx. So that's how we get there. So let's take a look. If we do this problem, I will use the remainder theorem to find f of negative 2 while you evaluate f negative 2 using your calculator. So let's actually try this. I want you to grab your calculator right now, and I want you to solve f minus 2 using, or f of negative 2 using simple substitution like we always do, right? So that is the form 2 negative 2 cubed minus negative 2 squared minus 4 times negative 2 plus 6. So I want you to solve that in your calculator while I solve this by long division. So it's almost just as fast. It can be faster in some situations than putting it into the calculator. So we're going to use this to solve some problems. So use synthetic division and the remainder theorem to find p of 3. So that means we're going to have 3 here. We're going to use our coefficients. So we have 1, negative 3. We're missing the x term, so we need 0 and 5. So we have 1 times 3 gives us 3. So negative 3 plus 3 is 0. So 0 times 3 is 0. 0 plus 0 is 0. 0 times 3 is 0. 5 plus 0 is 5. So, is x minus 3 a factor? So we know here that p of 3 is going to give us, the remainder is 5. Okay, so that's our solution for p of 3. You could substitute in 3 to this equation and you would get p of 3 equals 5. Now, is x minus 3 a factor of p of x? The answer here is no. And the reason it's not a factor is because if it was a factor, then the remainder would have to be equal to 0. So the fact that we have a 5 instead of a 0 is what lets us know this isn't a factor. So this is great for when we need to factor in the future. So let's take a look at another example. If we have negative x cubed plus 5x squared plus 8x plus 4, given that negative 1 is a 0, find the remaining zeros. So we're going to do this until we know all of the zeros. So we have negative 1, and we have 1, 5, 8, 4. And we're adding here. So we bring down our 1. 1 times negative 1 is negative 1. 4. 4 times negative 1 is negative 4. So positive 4. 4 times negative 1 is negative 4. So 0. So we know that we now have x squared plus 4x plus 4. Okay? Well, that's really easy. If we don't know what a solution is here, we can just factor, because now this is a quadratic, right? So this is x plus 2, x plus 2. So if you keep this in mind, what we're saying here is that x cubed plus 5x squared plus 8x plus 4 factors to, if x is equal to negative 1 right here, that means x plus 1 is a factor. So it factors to x plus 1, x plus 2, x plus 2. So our solutions then are x equal to negative 1 and negative 2. How cool is that? Let's look at another one. So here we have x to the 4th. So we know, given that both negative 4 and 1 are zeros of the function, factor this. So we know that we have 2 zeros of the function. So I'm going to start with 1. You could start with 4. It wouldn't matter. I'm going to start with 1. So I have 1 for my coefficient on the 4th. The 3rd is 9 squared, 22. Linear is not there, so I need to write 0 minus 32 as our constant. So then bring down my 1. 1 times 1 is 1. So 10. 10 times 1 is 10. So 32. 32 times 1 is 32. 0 plus 32 is 32. 32 times 1 is 32. So 0 here. So then we can do this again because we have this remainder and we've been told that we have another solution of negative 4. So 1 times negative 4 is negative 4. 10 minus 4 gives me 6. 6 times negative 4 is negative 24. 32 minus 24 gives me 8. 8 times negative 4 is negative 32. Positive 32 minus 32 is 0. So now I know that I have, remember, this gives me a factor of x plus or minus 1, right? Because it's the opposite sign. Minus 1 is a factor. This is x plus 4 is a factor. So the next factor we have is this, that comes from this green right here, x. Let me write that in purple since we were given that as well, just so I don't get confused. So then this green is what we found. We took away 2 of the solutions, so we started with 4, so now we should only have 2 left. So we have x squared. Let me turn back to green. X squared plus 6x plus 8 is the solution we found here with these already here, x minus 1, x plus 4. So this is the factor form of what we started with. So now I can factor this green portion, and that factors to x plus 4 and 2. So then setting each one of those to 0 will give you your zeros. So we have x equal to positive 1 from that first one, x equals to negative 4 from that first one. Then from here, that's going to go to x equals negative 4, so I don't need to rewrite it, and x plus 2 will give us x equals negative 2. So our solutions, which probably should be written in descending order, or ascending order, negative 4, negative 2, and negative 1. So this is our final solution. So why are we doing all of this? Because it will help us with our next lesson, 3.4, where we are graphing rational functions. So let's see how this can help us. We already know things about polynomials, right? We know here that this cubed polynomial, a(n) is 1. 1 is greater than 0, so we have a rising on the right. So we know, and then it is positive, n is 3, which is odd, so they have opposite. So we're going to have a graph that looks like this from what we learned last lesson. Okay, now we can use the synthetic division to find our zeros because we couldn't factor by grouping here. If you see this, there's nothing to pull out that works for factoring by grouping here. That's going to give us the same things. So that's not going to be pretty. So that's why we need the synthetic division in this case. So we know that x equals 3 is a 0. Somebody told us that. So we have 3. We have 1, negative 5, 3, and 9. And we know that we're going to have our remainder there. So we bring down our 1. 1 times 3 is 3. Negative 2. Negative 2 times 3 is negative 6. Negative 3. Negative 3 times 3 is negative 9. 0. So then we have x squared minus 2x minus 3. Well, now we can factor that easily because it's a quadratic. So we have x minus 3, x plus 1. So we already know that x equals 3 is one solution from up here. Now we have x equals 3 here too. So the multiplicity of x equals 3 we know is 2. So we're going to touch and turn. And so then this one's going to give us x equals negative 1. Its multiplicity is 1. So we're going to cross. So now we can do the graph, right? We know what we need to know. We also know that our y-intercept is at 9, right? Because if we put zeros in, we get 9. So we have a point, our y-intercept at 0, 9. We have a point at x equals 3 and a point at x equals negative 1. We know that this one's going up and this one's going down. We know that we cross the x-axis at negative 1. So let me put my arrow going down like that. And then we're going to have to turn at some point and go down and touch and go back up. It's not a very pretty picture. So down. Jeez Louise. Let me try my picture again. There we go. And then down and touch and turn. There we go. So our points, our y-intercept is 0, 9. The x zeros that we found were x equals 3, which is the 0.30, and then this point of -1, 0. All right. So that concludes 3.4.